Hello everyone, very good afternoon. This is Rohit Kumar and welcome to my YouTube video of class 1200, um, assignment number 2, Introduction to Data Analytics, and coach is Mr. Reza. And in this YouTube video, we are going to explain about mean, median, standard deviation, linear regression models, R2, MSE, mean uh, square error, root mean square error, and the difference between the predicted values. So let's start with the variables. And these are the variables Mr. Reza has given to us. Humidity, wind speed, visibility, pressure, and the dependent variables are temperature. So this is a particular set of data related to the weather conditions. And the data I have chosen is uh, from the independent variables, wind speed, and from the dependent variables, it's temperature. And let's jump into the code right now. And in this code, we are going to load the libraries first, such as pandas, numpy, matplotlib, lib, etc. And we have created a new section to give a new set of code in it. So first we are loading the data set. So to get the data, we have to go to files, go to this folder and click on these files, and it will have an option to choose the file. You can choose one of your Excel or .csv format file here, and then click on upload. And now you can see this one here, and the code should be right. We are reading the CSV file here, which is pd read CSV for the weather conditions. Make sure the code written, the naming convention should be same here and here as well. And now we are importing a particular data set of 100 values to DF2 because the data set which I have got is more than 90,000 values or near 2 million values. So I just wanted to take it only 100 values because it will be easier for us to understand this data instead of this 1 million values here. 1 million values will just give you a clumsy data here, which you can't understand right now. So I'm just taking as 100 variables, and I'm assigning it to a new variable df2. And for this, we are getting, this is the standard code for median, mean, and standard deviation for the temperature. And below are the values, which we have explained in the last video. And df describe will give you the count, mean, standard deviation, minimum and maximum values, also 25%, 30, 50%, and 75% of the values. And we are defining the x and y variables to get this graph here. And to get the graph, lm graph or lm plot is the syntax for this. And so what we are doing it here is we are just assigning the values, assigning the shapes, and assigning these integer values here. And in this regression visualization, we are visually displaying how the graph looks like in a real world. For that, we are taking x-axis and y-axis, and x-axis is set as wind speed and y-axis is set as temperature. And in this axis set title, we are going to choose how big the dots are, which is alpha, and what is the color I have to assign for this is blue. And what are the x and y axis values? We have to define it here. And in the next two lines, we are writing about the labels. And in these labels, we are selecting X label as wind speed, which is the size 20. This will explain the size of this label here and the color of the label. Also the alpha. Alpha is how deep you can, the contrast of a particular color of that value. And then we are going to describe about the box plot visualization. This is a simple code to get the box plot. And then we are going to get the linear regression values. And in the linear regression models, we are going to get intercept, coefficient, R2, mean absolute error, mean squared error, and root mean squared error. So let me, before going to the code here, let me explain the values of what is R2, mean absolute, and mean squared errors. So coefficient is the relation between the standard deviation to the mean, and the linear regression is a part of the regression model, and it is used to predict the values based on the previous set of data for a period of time. And the mean absolute value is the prediction examples between the observed values and the subsequent values in a data set of period of time. And R2 is the proportion values of the variance in the independent variable that can be explained by the independent variables. Mean square error is this will explain how close the points are fitted in a line. So in this code in the linear regression, you can see how fitted the values are. This shadow defines that these are the closed values for this linear regression line, and these are the outer part of this line. And in the root mean square, it's nothing but the square root of the mean square error to get a proper decibel values, and it will also helps us more understanding about the values. Then we'll go to the code here. In the linear regression, we are almost using the standard values, standard syntaxes here. The matrix mean absolute error, mean absolute error will get you the mean absolute error here in the format. Matrix mean square error will give you the mean squared error here, and the mean squared root error will give you the root mean squared error. And we are printing it as mean squared error and root mean squared error. And this is the format. And this is the forecast table here. And this is the prediction values. And we're just reshaping it into a particular data which can be more readable to us. And the difference is predict 2 minus y test. Whatever we have conducted the test here, we are just taking those values minus our prediction values. So the actual values and the predicted values. And that's the difference here. And we are importing it to a data frame, actual y test and the predicted values round 2. And we are also getting the difference of the amount, difference between the actual and predicted, and we are just passing it to this forecast table here, and we're just displaying it here. So this is how it should be done. Now, the last question is we have to explain about the three values, the three models or 3 points which we can use to improve the regression model. The first option is handling the null and missing values. This will help us. So in this regression model, 0 means error and 100 is no error. So instead of that, if you consider the null and missing values, it will be better to predict the data, and the data would be more realistic. And also implementing the more data visualization tools or more graphics to that will help us how properly this data is distracted from the linear regression, and how knitted the data is to the linear regression can be seen very easily. When we check it in this code here, you can see all the values, or like there are multiple values here, and you can see it's not visible here. If it's a 3D or any other dimensions, it will be easier for us to look around the 3D, and we can get the values around that. And then there are some of the features missing, such as the correlations between the attributes that we are going to predict. So it will be better if we can improve this feature. Helps us to get the more realistic values in our real world. And that's it. Thank you so much for this opportunity. We'll meet in the assignment 3. Thank you. Bye-bye.